video builds on the excellent support that teacher mentors already give students in their general planning, teaching and assessing in the classroom. Its aim is to help mentors to support students' science teaching. June Agar and Andrea Curtis are teachers at Rushey-Mead Primary School, Leicester. In this video, they're role-playing the parts of teacher, mentor and student. The scenarios are based on a wide variety of interactions between mentors and their students.
It looks sweet.
Both student and teacher mentor need to work together to optimise the student's development. This video shows ways of helping students improve their planning and presentation of science lessons. It focuses on one lesson in the context of several weeks' teaching experience. It starts from the student's first chance to talk about science. Before the student can start planning her first lesson, she'll need to find out about how science is organised in the class, what science topic will be studied, what resources are available, the children's previous science experience, and how science is assessed and recorded.
Ritesh, put your scissors down please, you should be listening. A jagged edge is a bit like an edge of a saw, it goes up, down, like that. So just try doing that with your finger.
It's helpful for the student to see how the teacher organises science and how the children respond to scientific activities.
While you're with us, we'll be doing changing materials. You could think about relating that to the children's everyday experience.
Part of the introduction should also include helping the student to prepare plans for the whole block teaching experience.
The bit of the national curriculum is this bit here.
In order to prepare suitable plans for several weeks, the teacher mentor will need to explain what topic will be undertaken and how it should satisfy the national curriculum requirements and the school scheme of work.
There's a box of resources you might find useful. Up in the staff room there's a fridge.
The student will need to be told how science is organised in the school and shown the school science resources and where they can be found.
Okay, and we've got teachers' books here.
Andrea will be focusing on changing materials. She needs to see equipment and teachers' handbooks. She'll also need to look at books to make sure her own level of knowledge is good enough.
This is where the children's non-fiction is.
Students should also look at children's books and other resources, such as computer software and CD-ROMs.
Which ones you do? This one and that one there. Right, lovely. You've done all this science work. I just have a look through.
As well as looking at resources, Andrea's finding out about the children's general ability by talking to them and looking at what they've written about science in their books.
Which one's the one with some compost and no water? That one. Okay. Which one's the one?
I think it's hard to remember what it felt like when you first started teaching. You do so many things instinctively, things like marking the register, getting the children's attention, that you have to remember to be explicit about techniques like this with a new student. They don't actually know these things.
I think it's important that students know right from the beginning the science topic that they're going to be teaching in order to plan for it. I think it's also important that you have a chance to talk to children and find out their ideas and to see what level they're working at. And it's also important to know the resources and books that are actually in school that you can use for your planning.
It's important to show the student where all the resources are, to give them access, maybe to go through some of the ideas and approaches that they might use, to give them a choice so that they can start to select what they think would be best for their medium-term plans.
That's brilliant.
Did you manage to get to talk to many?
The next step is to draw up a medium-term plan which the student and teacher mentor review together. June and Andrea have decided to use a checklist of the main features of good plans. These include thinking about satisfying the requirements of the national curriculum, identifying the skills, knowledge and understanding for the topic, developing these clearly and progressively, finding out the children's ideas at the beginning and throughout the work, as well as having realistic, interesting and relevant activities.
Have you thought about how you're going to find out what the children know already?
Well, I thought I'd ask the children to write their ideas down.
Right, now you've had a look at their books, you know the sort of work they're capable of doing. Do you think they'd all be able to do that?
Maybe not.
June is making sure Andrea will do a baseline assessment.
Ideas like maybe giving them pictures to sort, or perhaps having them all sitting on the carpet and doing a class brainstorm. There isn't an assessment technique that will cover everything, but I think perhaps if you tried one of those, then that one might give you a better idea of where they are, where you could start.
I thought we could make some chocolate crispies and chapatis, link it in with the
That'd be
cooking.
good.
Maybe
Later in the discussion, it becomes clear that Andrea's suggested order of activities introduces new science ideas to the children too quickly.
That's looking good. You might think about tying in exactly what you're trying to teach with each of your activities. And had you thought about what order you would do them in?
Well, I thought we'd be looking at melting and dissolving and to look at how different things melt.
Right. Melting is a little bit more difficult for children than you might think. Even children who are Year 6 children doing their SATs over the whole country, they do find melting quite a difficult concept.
So I need to spend a bit more time on that then.
I think I would, yes. You might.
It's important that the student feels able to raise questions and worries.
Well, I was looking through it last night and there was one thing that I noticed is that I haven't included a whole investigation. Do you think that's important?
I think that's very important, yes. You need to think about the skills, teaching the children skills in parallel with them learning the concepts. What could we do? Well, maybe you could think about an investigation into if different materials melt at the same temperature.
Right, yeah, I could do that. Have the children used a thermometer before?
Students very often try to plan much more than they're actually going to manage to do, but it's much better that way than not planning enough. And it does take a long time to go through the medium-term plans, but I always think it's really worthwhile. It means that we can talk through any issues that arise before they become problems in the classroom. And it gives me peace of mind because I know the children are going to get a sensible sequence of lessons.
I think it's worthwhile putting in the hard work, writing, discussing your medium-term plans at the beginning. That way you know roughly what you're going to be doing throughout the experience and it gives you much more time to deal with the everyday teaching.
Andrea is completing her first draft lesson plan by trying out the activity. Then at last she'll be ready to talk about her lesson plan with her teacher mentor.
Yeah, they're good, aren't they?
This discussion might take as long as an hour, much too long to be possible for all lessons. However, if the teacher and student can work intensively in this way for 1 or 2 science lessons during a 6 or 7 week placement, all planning and lessons should be enhanced. During their discussion, the teacher, mentor and student need to consider learning outcomes, the student's own knowledge, use of science language, ways of questioning children, how to deal with children's misconceptions, how to organise and use resources and equipment, and safety. Andrea has prepared a lesson on melting.
Well, basically I thought I'd start by telling them how some chocolate melted.
First, June asks her to talk about what she's going to do. This helps them both to focus on the topic.
Things melting and then the children would record their results and we'd follow up with a discussion at the end.
That sounds good. Shall we use the checklist? We'll go through that.
It's then useful to have a checklist to help the teacher mentor make sure things are not forgotten.
I can see you've got a reference.
A checklist empowers the mentor to ask awkward questions.
Do you want to tell me how you're going to start a lesson?
Right, well I thought I'd start by telling the children that I went to the shop before school, bought some chocolate and then it melted when I got to school.
Oh, that sounds good. That's going to grab their attention, isn't it?
Well, I thought I'd bring in the idea that I saw Mr. Miskin and he gave me a job to do.
The teacher mentor needs to be supportive and encouraging, but should also challenge the student's science ideas, organisation and realism, but without restricting the student's personality and creativity.
Chocolate is a reversible change, that I would put the melted chocolate into the fridge, then I'd bring it out to show that it's changed into a solid.
Although Andrea has a number of exciting ideas, she's planned to cover too many activities in one lesson.
Melting different everyday things and then talking about whether the change there is reversible or not.
That's quite a lot for one lesson, isn't it? I think maybe that's a bit too much.
Right, okay.
I wonder if it would be better to just focus in on one area that we can really achieve.
Okay.
How about just thinking about the melting for this first lesson?
Right, okay. Well, I thought after that, with the children, could melt some jelly in hot water. That would keep them interested.
Yeah, jelly in hot water is actually quite a difficult area. I'm never quite sure, is that melting or is it dissolving?
As the discussion proceeds, June realises that Andrea's own science knowledge is weak, and so helps her to clarify
It
it.
could be dissolving, couldn't it?
It's difficult, isn't it?
Yeah.
The way I've always thought of it is that if it's melting, then it's a solid that's turning into a liquid and there's heat involved.
Right.
Okay. And then if it's dissolving, then it's something mixing with water to form a solution.
Right.
So you can see that jelly in hot water is quite difficult. It's likely to cause confusion.
Yeah, it is, yeah.
Yeah. I think it would probably be better to stick to one or the other.
So if I concentrate on melting...
Confusion between melting and dissolving is common in adults as well as children. It's important to make sure concepts are clearly understood.
They could melt some butter, ice and wax.
Yeah, and how would they actually do the melting? How would you organise that?
Well, I thought they could use the hot plates that we saw in the cupboard, because that would ensure that the wax actually melts.
Yes, it would melt the wax, but there's a safety issue there as well, isn't it? It might be quite dangerous.
Yeah, of course it would be, yeah.
June has encouraged Andrea to give the children the chance for some hands-on experiences, but needs to be sure the activity will be safe.
Well, we could do it like I melted the chocolate with hot water in a dish and put the things in dishes or a bowl or something.
That would be a much safer way, wouldn't it? And we've got foil dishes and some bigger dishes that you could put the water in. That would be much safer.
Right. The only thing is, would the wax melt?
Well, probably not, but do you think that might be a good teaching point, that the children, you can bring out that... a lot of students have misconceptions about science, and it's much easier not to challenge if you've got a very bright, articulate student. But having that checklist there almost forced me into discussing that issue with Andrea over the dissolving and the melting, and we resolved the problem.
It's difficult to think you're going to have to rewrite your lesson plans, especially if you've worked really hard on them. But it's much better to do that than make mistakes while you're actually teaching. I think you need a mentor that's going to praise you when you do something right, but at the same time point out mistakes you might make and help you sort them out. On the way to school today, I felt very, very hungry. I thought to myself, what would I like to eat? Oh, I know, I'm going to buy myself some chocolate. Who likes chocolate here? I love chocolate. I can eat it day and night. So I went into the shop and I bought myself a chocolate bar, and I thought I'll eat it just before school starts.
The two learning objectives for the lesson are that the children will learn that things need heat to melt and that things melt at different temperatures.
If I open it up, let's see, what do you think's happened to my chocolate? Because it doesn't feel the same as when I bought it. Yes.
It's melted.
It's melted. How was it when I first bought it, do you think? What did it look like when I first bought the chocolate? Yes, go on then, Sachin, tell me.
Nice and smooth.
It was nice and smooth. Do you think it's smooth now? It's still smooth.
The start of the lesson was very good. Andrea had got the things, all the resources out on the tables. She'd got everything she needed for her demonstration. Everything was to hand and ready. She was obviously well prepared.
Is it still really hard? Right, tell you what, let's think about the words to describe it now. Okay? Runny.
The introduction was lovely. I really liked the story. That really got the children's attention.
Anything else?
I think she could have done more than just ask the children to describe what was happening to the chocolate. She should have started getting them to think about why it was melting at that point.
Together, and Lizzie, Artie and Divya, you're going to be working together. So, if you'd like to go and sit at a table, okay? And I'll bring the ice around?
She managed the class very well. The children all knew exactly what they had to do, and she went around the groups, she was talking, she didn't miss anyone out, and she had a nice friendly approach. The children were able to communicate with her.
That's completely melted. Is that completely melted? I want you to think about the words you can think to describe what's happening.
Andrea wasn't really focusing on the science in those activities. She was thinking about the practicalities of had they got the butter, was the water hot enough, when really I would have hoped she would have encouraged the children to predict what they thought might happen, to explain what was happening. It would have been good if she'd stayed with a group and really talked through, got the children to explain, describe, show what their understanding was.
Great, that's wonderful. Well done.
I was talking to one boy, and when the wax didn't melt, he told me that he thought it would melt if he put it in a fridge. It's an obvious misconception there, and that's the sort of thing that she needs to be picking up and talking through with the children to develop their understanding, and that really wasn't happening.
Stop writing. Sit down. Put your pencils down. This is what I'd like you to do. There's 2 trays by the sink. First of all, you can take the butter, you put that into one tray, and then you put the wax into the other tray, the one nearest the sink, and the water you can pour into the sink. Only the water in the foil containers, because I will come along and take this water because it might still be hot. Okay, the tray.
The clearing up was efficient. She managed that really well. I liked her recording method. That was nice that they recorded in groups. She didn't really leave enough time at the end for the children to discuss and think about what they'd learnt from their activities.
What did you write down to describe what happened when it just came out the cool box? The ice, first of all.
It was translucent.
Okay, what else did you write?
Looked solid.
Yep.
Hard. Smooth. Cold.
And cold. How did you know it was cold? You felt it, did you? Right, brilliant. Okay, what about the butter? What was the butter like?
When they were sitting together on the carpet, they did go through the charts, but there were so many opportunities there to draw out science, knowledge and understanding. For instance, how the different materials behaved, how the butter and the ice and the wax were different, and how they behaved differently when they were in hot water or just in air.
Smooth, right. To begin with it was opaque and now it's translucent. Right, okay, let's go on to the next bit. After 10 minutes.
The children should have been contrasting, comparing, drawing out so much science there, and that was missed really. She managed the lesson very well, but they didn't actually learn very much science from it.
Solid, translucent, and smooth.
Right, brilliant, that's fantastic recording. Give them a clap, well done. Sit down, thank you. Right, she's somebody who had it in hot water next, so let's have a look. Come on then, Katie's group.
I don't think the learning objectives were met really in that lesson. Andrea's 2 main aims were to teach the children that you need heat to melt things and that things melt at different temperatures. And I didn't feel that either of those were drawn out very well. I don't think Andrea knows if the children understand those points at all.
It's like a liquid, right, okay. And what happened to the butter after 5 minutes?
If only she'd concentrated on those 2 things at the end of the lesson and really drawn those out, then it would have been a very good lesson.
Right, brilliant, well done, give them a clap. Right, well done everybody, you've worked really, really hard this morning. I'm really impressed with all the words you thought of, okay? All those scientific words. Right.
Although June's clear about the main points she needs to discuss with Andrea, when they talk about the lesson, she needs to be careful not to tell Andrea what to do, but rather to encourage her to think about the issues for herself.
And Sanaya, that's Sanaya there, isn't it? Sanaya, you can go out for lunch. And
The debriefing discussion starts with the teacher encouraging the student to evaluate the lesson. They then use a checklist to make sure they've talked about all the main issues, such as whether the learning objectives were achieved and how Andrea knows that, how the lesson could be improved, how the children's learning will be recorded, and what the children should be learning next. Finally, they should agree an action plan to help the student improve some aspect of her teaching skills and knowledge.
Do you want to tell me about the lesson? What do you think went well?
Well, the children seemed to enjoy the activity.
They did.
They recorded well. I felt in control the whole time, and generally I think it went okay.
Yes, I think so too. You'd obviously thought really carefully about exactly who was going to do what when, and that really showed.
Although Andrea's doing well and has satisfied the generic standards, she hasn't developed the children's science learning enough. June tries to help her improve her discussion and questioning.
Do you think there were any problems at all? Do you feel you achieved what you set out to achieve?
Maybe I was a little bit rushed at the end.
Yeah.
I could have got the children to clear away a bit sooner, and then we could spend a bit more time talking about their work.
Right, yes. And you've got some really good recording sheets there. I like the way they recorded as a group, and the sheets were very, very clear. Now, I think maybe you could have used those a little bit more at the end to really focus on the children's learning. What have they learnt from that activity? Just because they've done an activity doesn't necessarily mean they've learnt anything from it. And that would have been a good check for you and a way of assessing their learning. Do you think there are any other ways in which you could have encouraged the children to share their ideas and you could have assessed them perhaps in other parts of the lesson?
Well, I could have looked a bit more closely about what they'd written.
How about when you were moving around the groups?
Oh yes, I suppose I could have checked their learning then.
Yes, I think that would have really helped them if you'd been around sort of asking them to predict what they thought might happen and then asking them to explain what they saw and perhaps asking them why, to draw out their ideas as you were working with each group in turn.
Finally, June and Andrea identify points for action.
Now, we need to think about some targets, don't we? So what do you think you need to focus on in your science teaching?
Well, I think I need to spend more time thinking about and talking about the science and questioning the children better.
Yeah.
Maybe if I can think of a list of questions, you could have a look at them before the next lesson.
Yes, good idea. Perhaps we can arrange to meet next week after school. That would be great. Okay. What about the next lesson? What were you thinking?
It's not always necessary to watch the whole lesson. In this case, as June and Andrea have agreed to focus on questioning, in the next science lesson, June may only need to watch parts of the main activity and the final summary.
I think my main aim would be to help students to be reflective and critical about their own practice. To look at the lesson they've just taught, and if it went well, then to identify why it went well. And if there were things that didn't go quite so well, then to be able to pick up on those and to think about what the problem was, why things didn't go quite so well, how can we improve it next time. I don't do this by saying, oh, that was good, or I didn't like that. I try and use open-ended questions. I will focus on an area where maybe I thought there was a slight problem and help the student to talk through that for herself so that she identifies or he identifies exactly where the problem was. In a while, they're actually going to be out in classrooms and they probably won't have a mentor by their side. So they need to develop these skills for themselves. They need to be developing their own practice all the time. And so I think that is the most important thing I can do for them. I've been teaching for a long while and hopefully I still do that. I still criticise my own lessons and try and develop my own practice. That's what they need to be doing through their teaching career.
So, to sum up, helping students to develop their science teaching involves introducing them to the way science is organised in the class and school, guiding them to produce medium-term plans, helping with 1 or 2 science lesson plans, observing and discussing science lessons, encouraging self-reflection and helping students to decide how to focus their future effort to improve their ability to teach science.
Mentoring is very time-consuming, very demanding, but for me it's worth the effort. Students can ask very challenging questions and make me think about things that I've been doing automatically maybe for years. I have to break down exactly why I'm doing something, how it works, why it is successful. So the discussion that goes on between mentor and student is of great benefit to the mentor as well, hopefully to the student.
Teaching practice can be stressful at times because you're having to take advice from somebody and that can be difficult, and there's this real pressure that you've got to improve all the time.
Which one's got smooth edges and which one's got jagged edges?
At first, science teaching can seem daunting, especially if you're not a science specialist. But I found it useful to go back and think through ideas and concepts. That helps you get your teaching right. That means that the children can enjoy the science, you enjoy the science, and they come up with some great ideas.
For me, having student teachers is an advantage. For the children, it's a fresh face, new approaches, they always bring in new ideas, so it's great for them. And for me, well, it's really good to have an adult alongside to talk through the science. I'm not a science expert, so I need to talk through the science. I need to think about exactly what I'm teaching the children, if I've got the right ideas. So the two of us together can work through those issues, and it helps me as well as it helps the student.